to the massive earthquake that woke up Alaska.
Now breaking news, a powerful earthquake has struck southern Alaska, triggering a tsunami.
The threat looming beneath Alaska's southern shores and the broader Pacific Rim is no longer a distant theory. It is an increasingly urgent reality. In 2025, a convergence of seismic tremors, volcanic stirrings, and mounting geological data has shifted the focus of the scientific community to the Aleutian Subduction Zone. This vast tectonic boundary, stretching across a remote chain of islands, is demonstrating all the hallmarks of an awakening giant. The recent 7.5 magnitude earthquake near Sandpoint, Alaska, served as both a literal and metaphorical jolt to experts who have been tracking subtle warning signs for years. 8 earthquakes of magnitude greater than 5 struck the Andreanof Islands in a mere 48-hour span, which is neither common nor inconsequential. Such seismic clustering signals an unstable fault system experiencing rising pressure and stress transfer, patterns that mirror those observed before historical disasters like the 2011 Tohoku earthquake in Japan. What distinguishes the Aleutian Subduction Zone from other fault lines is not just its geological energy, but its deceptive quiet between major ruptures. These tectonic plates don't give away their secrets easily. They compress and grind silently until the accumulated strain becomes too much to bear. When this happens, the resulting release is not merely a local disaster, but a globally impactful event, particularly due to the risk of triggering a mega tsunami. Volcanic islands in the region, such as Mount Cleveland and Mount Shishaldin, are not just towering cones of rock and ash. They are perched precariously on loose, unstable foundations that become even more vulnerable when shaken by seismic waves. If a flank collapses or if underwater slopes give way, the massive displacement of ocean water can unleash towering waves that travel at jetliner speeds across the Pacific. Satellite measurements, sonar mapping, and deep sea exploration have revealed unsettling features beneath the waves. Massive submarine landslide scars stretch for miles across the ocean floor, evidence of past events powerful enough to trigger waves hundreds of feet high. Some of these features are geologically recent, suggesting that the risks are not just theoretical. In 2017, a remote landslide near Tan Fjord in Alaska created a tsunami nearly 600 feet high. That event was far from any major population center, but a similar collapse in the Aleutian Islands, especially near vital shipping routes or during fishing season, could lead to catastrophic loss of life and infrastructure damage across continents. The threat isn't confined to Alaska. Historical tsunami models show that waves originating from this region have impacted California, Oregon, Hawaii, Japan, and New Zealand within hours. These waves are indiscriminate, overwhelming coastlines regardless of their development status or population density. The geography of the Aleutian Islands compounds this danger. Their steep slopes, unstable geological composition, and proximity to major tectonic boundaries create ideal conditions for a cascading disaster. One event, whether an earthquake, a volcanic eruption, or a landslide, can trigger a chain of subsequent hazards that amplify the destruction many times over. Beneath the sea, a more invisible threat is brewing. Submarine volcanoes in the Aleutian Arc, many of which remain unnamed or poorly monitored, are showing signs of unrest. Seismic sensors have detected clusters of low-frequency tremors, typically a precursor to magma movement. NOAA and the Alaska Volcano Observatory have used remote-operated vehicles to observe increased temperatures and gas emissions from hydrothermal vents. The discovery of new fissures adds further evidence that these submarine systems are becoming active. Unlike land-based eruptions, which leave behind visible scars and ash deposits, underwater eruptions can be both hidden and profoundly dangerous. In confined or shallow oceanic spaces, even small eruptions can displace vast amounts of water and destabilize already precarious slopes, leading to unexpected tsunamis. The multi-hazard potential of this region is what concerns scientists most. Volcanic eruptions here don't occur in isolation. They interact with tectonic stress, sediment instability, and dynamic seafloor environments. A submarine eruption might shake loose a slope, trigger a fault rupture, or cause seafloor uplift, all within minutes. The resulting compound disaster would not just impact Alaska, it would send ripples across the entire Pacific Basin. In the worst-case scenarios modeled in recent simulations, a synchronous earthquake and volcanic eruption could generate tsunami waves powerful enough to engulf major coastal cities thousands of miles away. Historical understanding of the region's seismic and tsunami activity has been significantly enhanced through geological investigations. Researchers have examined ancient deposits, sand layers, uprooted trees, and marine debris embedded far inland to piece together a timeline of prehistoric tsunamis. These studies reveal that the Aleutian Subduction Zone has a history of producing enormous waves, some of which dwarf the largest tsunamis recorded in modern times. Core samples from coastal marshes show saltwater deposits and ocean shells embedded miles from the shoreline, suggesting massive flooding events. These findings underline the fact that what has happened in the past is not an isolated anomaly, but part of a recurring cycle of destruction that could strike again. Despite the wealth of geological knowledge now available, predicting these events with precision remains elusive. Modern technology offers a range of tools: GPS sensors that detect crustal movement, tilt meters measuring the deformation of volcanic slopes, ocean bottom seismometers, and deep sea pressure sensors, all aimed at capturing the earliest signs of trouble. Yet the complexity of interactions between tectonic plates, volcanic systems, and marine slopes makes it incredibly difficult to determine which signals are true warnings and which are harmless background noise. For example, the recent swarm of earthquakes in the Andrianoff Islands fits several precursor patterns but lacks the definitive signals required to predict a specific imminent rupture. Even so, the hope for earlier detection continues to drive research and innovation. Scientists now believe that even a few days' warning could dramatically increase survival rates, particularly for isolated communities with limited emergency infrastructure. At the same time, they acknowledge that not all events will announce themselves with clarity. Some may strike without recognizable warning signs, leaving residents and emergency responders with mere minutes to react. This is especially troubling for the small villages and towns spread across the Aleutian Islands, where rugged terrain, minimal road access, and limited communication systems could compound the tragedy. At the January 2025 USGS Subduction Zone Science Summit held at the University of Washington, the gravity of the situation was made painfully clear. Scientists, geographers, and disaster preparedness officials convened to analyze recent data, refine hazard models, and revisit lessons learned from past disasters. Discussions were marked by urgency, not speculation. Panels examined the effectiveness of current tsunami warning systems, the possibility of false alarms, and the psychological and logistical barriers that prevent rapid evacuation. Field reports highlighted crumbling evacuation routes, outdated infrastructure, and the cultural challenges in convincing isolated communities to act swiftly in the face of danger. Participants shared sobering insights from prior global disasters: the failure to interpret early tremors correctly before the Indian Ocean tsunami of 2004, or the communication breakdowns during Japan's 2011 event serve as stark reminders of the cost of complacency and miscommunication. The consensus at the summit was unequivocal: the Aleutian Subduction Zone is one of the world's most dangerous geological systems, and the only real defense lies in vigilance, education, and continuous investment in research. There is no way to prevent these events, but understanding them better may offer the slim margin needed to save lives. Adding complexity to the Aleutian threat is its possible connection to the Cascadia Subduction Zone, another tectonic fault known for its seismic potential. Cascadia stretches from northern California to British Columbia and, like the Aleutians, has a long interval between ruptures. Geological evidence suggests that large events in one zone may influence stress conditions in the other. While the probability of simultaneous ruptures is low, it's not negligible. In other parts of the world, seismic events have triggered pressure shifts hundreds of miles away, suggesting that what happens in Alaska could very well influence geological behavior along the Pacific Northwest. This interplay raises unsettling questions about the interconnectedness of tectonic systems. Could a megaquake in the Aleutians trigger aftershocks or stress redistribution along Cascadia? Could it lead to a dual-zone disaster that paralyzes the Pacific Rim? Although current models are not definitive, the growing body of evidence urges preparedness on a much broader scale. Emergency planners, therefore, must not think in terms of isolated zones, but consider the regional, even hemispheric implications of a major geological disturbance in Alaska. Further complicating the picture is the undersea environment where many of these events originate. The ocean's depths conceal much of the evidence, making real-time monitoring difficult. Submarine volcanoes don't emit smoke plumes visible from afar. Their eruptions, collapses, and seismic disruptions often go unnoticed until the damage has already begun. The development of underwater drones, sonar imaging, and seafloor mapping has started to change this, revealing a hidden world of dynamic geological activity. However, our understanding is still in its infancy. Much of the Aleutian seabed remains unexplored, and the risk posed by unknown underwater features continues to loom large. In light of all this, the silent signals of Earth's internal tension grow louder. Each microquake, each strange bulge on a volcano's flank, each temperature spike at a hydrothermal vent is another brushstroke in the evolving picture of potential catastrophe. The goal of scientists is not just to read these signs, but to translate them into action, timely alerts, informed policy decisions, and life-saving evacuations. But as technology races forward, so does the Earth's unpredictability. The greatest challenge may not lie in detection, but in interpretation, in separating noise from threat in a landscape as volatile as it is beautiful. The time to act is now. The Aleutian Islands have awakened, and whether this is a prelude to something larger or simply a period of increased activity, no one can say for sure. What is certain, however, is that ignoring the evidence would be a profound mistake. The Pacific Ocean has a long memory, and it is littered with the remnants of civilizations caught unaware. In the face of such overwhelming natural forces, our only real power lies in knowledge, preparation, and humility before the planet we call home. The illusion of calm must not lead to inaction. The Earth has whispered, now we must listen before it roars.